In a Malaysian heatwave, mechanical air conditioning runs almost continuously. That constant draw is often the single largest expense on a monthly utility bill, and it leaves your home's comfort entirely dependent on a grid that can fail during peak demand. The alternative is an earth air tunnel. By routing air through the soil beneath your property, you can tap into a stable underground temperature to lower your indoor air temperature without using grid power. However, building this in the tropics introduces a specific challenge. Pushing humid air into a cool underground pipe causes immediate condensation. If that moisture isn't managed, the tunnel will eventually introduce mold spores into your home. By pairing the physics of geothermal exchange with strict drainage rules, you can construct a cooling loop that functions regardless of the humidity or the status of the electrical grid. The project begins with the footprint. You need a linear stretch of yard space measuring between 50 and 70 feet to accommodate the underground pipe run. The depth of the trench is critical. You must excavate to a depth of at least 4 to 6 feet to reach the necessary thermal conditions. This illustrates the geothermal sink. Surface soil absorbs the sun, but earth at this depth remains cooler. The 50-foot pipe provides the residence time needed for air to shed its heat into the soil before entering the house. If the trench is too shallow, under 4 feet, the pipe remains within the sun-heated topsoil. The air will not cool, rendering the entire installation ineffective. The soil itself acts as the primary heat exchanger. Digging deep enough to reach that stable thermal mass is what makes the system work. For the pipe network, you must use unglazed terracotta rather than standard white PVC. PVC is a thermal insulator. Its chemical properties are designed to resist heat transfer, which prevents the soil from cooling the air traveling through the pipe. Terracotta is highly conductive. This porous, baked earth allows the heat from the air to move rapidly through the pipe wall and into the cool ground. This conductivity triggers a byproduct in the Malaysian climate. When humid air is cooled by the pipe, it reaches its dew point, causing liquid water to collect inside the system. To manage this, you must install the pipe at a tube. The airflow begins at the intake pipe, located at the far end of the yard. This intake must be capped with a heavy-duty stainless steel mesh filter. This mesh acts as a physical barrier against tropical insects, rodents, and debris from heavy monsoon rains. Near the house foundation, you should install a vertical T-junction. This serves as a capped access point for the system. This allows you to perform an annual maintenance check, using a camera or a brush to ensure the line remains clear of obstructions. To move the air into the home, install a small 12-volt DC fan inside the interior floor vent. Connect this fan to a small solar panel mounted outside. When the sun is out, the fan activates, drawing cool air into the house. By combining the geothermal exchange of the earth with a solar-powered fan, you create a consistent airflow that functions independently of the grid. Once the system is active, you can feel a steady stream of air entering through the floor vent. In a 95-degree heat wave, the air exiting the vent can drop to approximately 82 degrees. While this isn't as cold as refrigerated AC, this 12-degree delta provides significant relief by constantly replacing hot indoor air with tempered air from the ground. Keeping the system operational requires very little upkeep. You only need to wipe down the intake mesh once a month and check the access port for debris after the monsoon season. By using the thermal mass of the earth, you provide your household with a consistent source of cooling that remains functional even during power outages or rising energy costs.